Hello and welcome to this video for Module 3 Forces of Motion in the Motion subtopic for the topic of scalars and vectors for OCR A-Level Physics. So in today's lesson we're going to be looking at scalars and vectors and look at how to define and sum scalars and vectors. So if we've been successful and we've learned in today's lesson, we should be able to describe the differences between scalar and vector quantities. Should be able to add vector and scalar quantities, and then finally draw vector diagrams for vectors where the size and the direction of the arrow represents the size and the direction of the vector. So in today's lesson we're going to be looking at the following parts of the OCR A-Level Physics specification. We're going to be looking at 2.3.1 scalars and vectors. So we're looking at scalar and vector quantities, vector addition and subtraction, and vector triangles to determine the resultant of any two coplanar vectors. So, scalars are quantities which only have a magnitude or size associated with them. So this includes quantities like mass and temperature and length and time and energy. Now all these quantities have a magnitude, but they do not have a direction that they act in, they just exist. Now vectors are quantities which have a magnitude and a direction associated with them. So this includes quantities like weight, momentum, acceleration, force and velocity. Now all of these quantities have both a magnitude and a direction with which they act in. So to clarify, scalars are quantities which only have a magnitude associated with them. Vectors are quantities which have a magnitude and a direction associated with them, and we must treat these concepts differently both mathematically and conceptually. Now some quantities have a scalar and vector counterpart. In these examples, the vector is the scalar with a direction added. So examples include speed being a scalar and velocity being its equivalent vector. And for the scalar is the distance travelled, and the vector equivalent of distance travelled is displacement. Now in fact we can illustrate the difference between displacement and distance travelled with the following diagram. So you can see in this particular diagram that the distance travelled is the red path of the journey and the displacement of the journey is the blue path. So whilst the distance travelled is the overall motion of the object, the displacement is a vector pointing from the starting to the finishing point of the journey. Now, vectors are scalar values in some instances with a direction included in the answer. Now, the easiest way to add a direction is to place either a plus or negative in front of the value. So, for example, plus 20 meters per second and minus 20 meters per second show that the object is moving in opposite directions. Now the direction of the vector can also be given as an angle, either from the vertical or the horizontal, or the direction of the vector can be given as a bearing. Now bearings will always measure the angle clockwise from north. Now having a vector as part of a calculation of a value makes the calculated value a vector. Now having only scalars as part of a calculation of a value make that calculated value a scalar. So in physics there are two types of quantities. Scalars, which are quantities such as speed, have a magnitude but no direction associated with them, so they can be fully described only by a number and a unit. Whilst vectors are a quantity which is only fully specified with both a magnitude and a direction given. So it's not sufficient enough to know that a force has a magnitude of 300 newtons, we need to state the direction it acts in. So for example, a force of 300 newtons acting horizontally in a direction 30 degrees east of north. So scalars can include mass, temperature, time, distance, speed and energy, whilst vectors include displacement, force, velocity, acceleration and momentum. So here is just a table to summarise the most common type of scalar quantities you can find in A-Level Physics and its associated SI units, and then the most common vector quantities found in A-Level Physics with their associated SI unit. Now to add any two scalars, you can add or subtract the values from one another in the usual way. Now scalar quantities must have the same units when you add or subtract them, and scalar quantities can also be multiplied or divided by one another. However, the units can be the same or different. Now the units of the final product will change depending on whether they're divided or multiplied. Now to add any two vectors, you must draw a scale diagram. Now these diagrams accurately show the size and direction of the overall vector. So here is an example of a scale diagram where the resultant vector is the sum of vector 1 and vector 2. Now the overall vector is sometimes called the resultant vector. Now you cannot just simply add vectors, because the resultant vector is the straight line distance from the start of the vector to the finish of the vectors added together. Now this method of working out the resultant vector is known as the triangle method. So to draw a scale diagram, you must firstly set a scale to your work. So for example, you could say 1 square equals 1 Newton. Now scale diagrams can be used for any two vectors. You would then draw in the first vector with the correct length and direction. Remember to draw the arrowhead of your vector in your diagram. You will then draw the second vector with the correct length and direction, and you place this tail of vector at the head of the previous vector. Now that is why another name for a scale diagram is a head to tail diagram. So you can see here that the head of vector 1 is at the tail of vector 2. Now the resultant vector is from the tail of vector 1 to the head of vector 2, as drawn in here. Now you've got to remember to show the arrowhead of your resultant vector. You can then measure the length of this resultant vector with a ruler and the angle with the protractor, and convert the value measured with the length of the ruler with the scale to an actual value. Now it's also important to note that when given an angle, remember to start from where the angle is measured from, so either the vertical or the horizontal. And in most cases it's actually easier to measure the angle from the vertical. Now to subtract vectors, you must make one of the vectors a negative value. So this would mean that the vector is placed in the opposite direction before our triangle is drawn in as shown. So this would actually give a different value for the direction of the vector. Now, so let's just clarify. To add vectors, you must draw a scale diagram. These diagrams accurately show the size and direction of the overall vector. So to draw the scale diagram, you must set a scale to your work. Draw the first vector with the correct length and direction. Then draw the second vector with the correct length and direction, placing the tail of this vector at the head of the previous vector. Then the resultant vector is from the tail of vector 1 to the head of vector 2. You would then measure the length of the vector with a ruler and the angle with a protractor, and remember to convert with the scale. Now you might have realised in this previous method you have drawn a right angle triangle with your two vectors. This means you could calculate the length of the resultant vector with the Pythagoras theorem and calculate the angle of the vector with trigonometry. But be aware that this can only work if the two vectors are perpendicular or coplanar to each other. So for example, we can say here that the resultant vector squared is equal to vector 1 squared plus vector 2 squared, and the tan of the angle is equal to vector 2 over vector 1. Now this comes from SOHCAHTOA. For any right angle triangle where you know the two sides, you can work out the size of the angle. So we know sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. So we can use this Pythagoras method if the two vectors are at right angles or coplanar to each other. So you can actually say you can work the length of the resultant vector with the Pythagoras theorem by saying resultant vector squared equals vector 1 plus vector 2 squared, and that the tan of the angle is equal to vector 2 over vector 1. So you can see here an example of the calculation using this method. So if you have a vector acting 12 newtons to the north and then 8 newtons to the east, you can then say the resultant vector squared is 12 squared plus 8 squared, which is equal to 208, which then square rooted gives you 14 newtons, whilst the tan of the angle is tan theta 8 over 12, which is 34 degrees from the horizontal. Now if you have two vectors which are not at 90 degrees to each other, you can still add them via scale diagrams. So you can set your scale, for example, to be 1 centimeter is equal to 1 newton. So to find the resultant vector, you must use the parallelogram of forces. So this is sometimes called the parallelogram method. So you would set up your two vectors, vector 1 and vector 2. So you would then have your in your first step, draw in the same length vector as vector 1 with the same angle on the opposite side of vector 2. You would then do the same, and in the sense you would draw in the same length vector as vector 2 with the same angle on the opposite side of vector 1. With that, you've produced a parallelogram of forces. You would then draw in a resultant vector from the start of where the vectors are to where the new lines meet up. Then to measure the size of the resultant vector, you would measure the vector with a ruler and then convert it to a value with the scale. And then to find the direction of the resultant vector, you would measure the angle with a protractor. Now to subtract the vectors, like in the previous example, you will have to make one of the vectors a negative value. So this would mean that the vector is placed in the opposite direction as shown on the screen. So you would once again draw in your two lines to make it symmetrical. You would then draw in your resultant vector and measure your angle, and if you subtract in the vectors, you'll notice it will give you a different value for the direction of the vector. So thank you very much for watching this particular video on scalars and vectors. In today's lesson, we've looked at how to define what a scalar is and how to define what a vector is. We looked at how to add and subtract scalars, and we've also looked at how to add and subtract vectors by the triangle method, the parallelogram method, and by adding if they're in the same plane. So thank you so much for watching this video, which is part of Module 3, Forces and Motion, in the topic of 3.1 and in the subtopic of scalars and vectors. Thank you so much, and as always, have a lovely day.